Hello, my name is Lawrence Elliott, and I'm here with the Solar Microgrid out of Harmony Science Academy North Austin. And this is a project that came out of TEAS, which is a program that's partnered with A&M. And the purpose of this was to create a completely renewable energy powered microgrid. And a microgrid is any sort of electricity producing and delivering device that is separate from the international or the network that we have in the United States that we see all around us all the time. And so what we decided to do was to actually have our class plan, design, order, and actually build this entire thing. So this entire concept that you see was designed within our class of approximately 9 students. And so Lawrence Elliott, I was the project manager, and Angel Gaspar was the head of mechanical design and actual construction, and he can tell you more about some of his experience.
Well, hi, my name's Angel Gaspar, and I'm a senior. I helped construct this last year, and I was a big major part of the mechanical aspect of this whole project. And as you can see, the main support that we used to make this was angle irons with the holes pre-made. And one of the biggest issues, as you can see right here, we had to make it a specific size because we had to deal with a constraint with the size of a door. So we had to make it just the right size so it can fit through the door. And as you can see right here, we did it about approximately, we just had 2 solar panels. We were gonna add more, but due to the constraint we added less. And as you can see right here, for the major floor, we did wood, which is really hard wood. It's very durable. And for the batteries, we made an enclosure for each one of the batteries, so as they're in the colonias, they won't move a lot or cause the whole cart to move. The wheels, we had to find special wheels to hold up all this material because it's about 650 pounds. So each of these wheels, we have 4 in total. They both support, all 4 of them support the weight of the microgrid, and each one of them, they were about $80 each. And as you can see, we did a support kind of flatbed for the panels to help them lay down completely flat, and which is connected to this rod that every half a minute it turns at a specific angle to get the perfect sunlight to produce into energy. And as you can see, we have a beam running through the whole middle that helps balance out the whole solar panel bed, which we could either, as you can see right here, we could either have the panels facing like this. We have 2 different angles we could have it. They could be facing like that, or we could actually lift it up even more. Just depend on the type of angle we are, where the sun is located, which we could calculate it using the tracker or based on the angles.
Okay. From an electrical standpoint, we have 2 225-watt panels. So under optimal conditions, these panels will be able to produce 450 watts, watt hours. And our battery bank that we have at the bottom can store at approximately 7,000 watts. So fully charged, we could plug this into a house and be able to supply that house with a steady stream of 60 watt hours for approximately 4 days. So we can convert that into many different uses depending on whatever the colonia is needed. So to kind of give you some perspective, this wouldn't really be very much for a single household in your typical suburban American house, because we use a lot of power. Like this could probably power a microwave for a few hours. But for a colonia, they don't have these high demand electronics. So this would mainly be used for low things like lights or maybe some air conditioning. But we really try to avoid things that require heat, because the electrical components like ovens and microwaves, those type of things require a lot of energy, because heat requires a lot of energy because they actually get the heat. A lot of it is wasted and friction, and that's light. So that's why we try to avoid those when considering that. But also, our tracker came out of Red Rock Solar, and it's an independent contractor. We had a contact from our teacher last year, and it was kind of built from scratch just for this project. So it's fairly unique. You won't see another one of those on the market. You can't just go somewhere and buy that. So that's pretty unique. Our gear motor and our speed reducer determine the speed of this. We have it set to a very specific speed, and that's because we want this to be as accurate as possible. So most of the time when we start it up, people don't believe that it's actually doing anything. They can hear it, they can kind of see it moving over there, but they don't see the panels moving. And that's because we have it rotating at a speed of about 18 rotations per day. And it takes that much to go 120 degrees. So it's going really slow. And the reason that is that it's actually accurate to a fourth of a degree to the sun. So that's fairly accurate. And we're trying to do that because the faster it goes, the less accurate it would be, and it would be wasting energy trying to correct itself continually. So the way the tracker works is that we have two LEDs, and the LEDs are measuring the different amount of sunlight that they're getting. So if they're registering two different amounts of sunlight, we realize that the solar panels are parallel to the sun, which is the optimal condition, parallel to the sun. And so what they do is that they try to balance themselves. So they send signals to the motor to sort of right itself until it's at the optimum angle. And once it gets there, it will send no more signals, or it'll send a neutral signal. And that signal tells the motor to stop turning until the sun has moved, and then it will respond again. So we have two settings for our solar tracker. We have a manual, and then we have an automatic. And the automatic is what we would typically be on throughout the day as it tracks the sun. But then there's also the manual if we ever need to get it to a certain position. And that would have it running continuously at its speed. I believe that's about it. Is there anything else you like that?
Well, we also added a couple of switches that are back here. So say right now, since it's an auto track right now, if it reaches a point where the angle reaches all the way down here, we have a wood that has a little sensor that as soon as the panels or the little flatbed touches it, it sends signals back to the motor telling it to stop rotating because we don't want to constrain it and damage it even further. And we're actually the only school that actually got a solar tractor to work out of the whole schools that were participating in this. But throughout, it came out pretty good. Our experiences, I've enjoyed doing this project. We actually, it was an elective, so we chose to go in this class. So you get to work with other people who were dedicated rather than just students who were put there because they had to take it. And we also showed up many Saturdays to help work on this, just to get it done with. And it was a fun experience for me. We got to use different tools, and for example, I knew how to use an angle grinder. I would teach other people how to use angle grinders, so we also learned other valuable skills that we can use in the future. But other than that, we worked as a team together, and it came out pretty good.